Okay, level 4, number 1. We have a frisbee. I'm going to write down the two positions of the frisbee. Position 1 and then position 2, which is a higher position. At position 1, we have a height and we have a velocity. The height happens to be 1.1 meters. And the velocity is 12 meters per second. But we're also given both the height and the velocity at position 2. The height at position 2 is 2.1 meters. And the velocity is 10.5, a little bit slower. So it's gone higher, it's gained gravitational energy, but it's lost kinetic energy. Now you might be tempted to think, oh, I'm going to do the total energy at position 1 equals the total energy at position 2, and I'm going to figure something out, right? But the problem with this is you've already got all the answers. You know both heights and both speeds. So this equation really isn't going to help you get anywhere because you already know everything. Instead, what you need to realize is you already have the total energy at position 1 and the total energy at position 2. You can figure them out. So let's do that. Let's do the total energy at position 1. And in fact, they're not equal. That's what we're going to find out, because obviously some has been lost due to air resistance. So if we do the total energy at position 1, there's going to be Eg and Ek. So mgh and 1/2 mv squared. And that's going to let you figure out a number of joules. And you'll get that number. Then you can figure out the total energy at position 2. Right? And that would be equal to Eg2 plus Ek2. So mgh2, 1/2 mv squared, and you're going to get another number. This is the energy at position 2. So it's going to be different because we're assuming that some is lost. Some is lost due to air resistance. So essentially, if we take the initial energy and we subtract from it the other energy that we got, that will tell us how much is lost. And then in order to get a percent, well, we write how much is lost over the total energy at the beginning. What percent of the original energy, which is the smiley face. So actually, I'll just I'll rewrite that. That's the smiley face. That's the number that shows the total initial energy, and then times 100%. So by figuring each one out, we can subtract them to figure out how much is lost. And then we can do this little percent to figure out what the percent reduction should be. And it should work out to about 9%.